All right, this is section A3, day 1, and it's the in-class notes. And we're going to start out with the angle between two vectors. If theta is the angle between non-zero vectors A and B, then the cosine of theta is A dot B. This is called the dot product over the magnitude of A times the magnitude of B. In example 3, find the angle between two vectors. Find the angle theta between vectors u and v to the nearest tenth of a degree. We can already see that's 125 degrees, but let's use the formula to get that answer. We have the cosine of theta, cosine of the angle, is equal to, and we're going to do u dot v over the magnitude of u times the magnitude of v. So the dot product is 6 times negative 4, so you multiply the x's. That's negative 24, and we add that to, it's always addition, always, always, always addition. Then we multiply the y's. So we're going to add 6 to that. Over the magnitude of u is the square root of 36 plus 4. It's really the Pythagorean theorem on 6, 2. Then we're going to multiply that times the square root of 16 plus 9. 16 plus 9. So that gives us negative 18 over the square root of 40. And that's going to be 25. Square root of 25 is 5. So I'm going to grab the mouse here, and we're going to go negative 18. There's a couple ways to do this. You can just, here's the best way, I think, the easiest. Just divide by square root of 40, and then divide by 5. Now that number has to be less than, or it has to be between negative 1 and 1, because we're going to take the inverse cosine of that answer. So negative 0.569, let's say. And so theta, the angle, is going to be the inverse cosine of negative 0.569, but we're going to use the whole number, of course. Inverse cosine of the answer, and there's the 124. Now they said to the nearest tenth, but in the diagram they round it to the nearest degree. Oop, where'd my cursor go? There it is. So this is equal to 124.7 degrees. Now I want to show you that, well, let's just do the next one. We have the cosine of theta is equal to, well, we can call this u, we call this v, but it's the dot product, so negative 4 times 3, that's negative 12, and then 2 times 6, that's plus 12, over the square root of, there's really no reason to finish this because the top is going to be 0, but let's do 20, right? 16 and 4 is 20, and then square root of 9 and 36 is 45, but that's just going to be equal to 0. So now we want to know where the cosine of theta is 0, and that's at 90 degrees. Now if we make a quick little sketch of this, negative 4, 2, 1, 2, 3, 4, 2. So there's the first vector. And then 3, 6. 1, 2, 3. 1, 2, 3, 4, 5, 6. This is a 90-degree angle. So anytime the dot product is 0, then the two vectors are what they call orthogonal. In other words, they're 90 degrees. 90 degrees. Orthogonal is the term for perpendicular vectors. So now that they were kind of going backwards because I thought it'd be a little easier to see it, you know, using the formula to find an angle and then show why they would be orthogonal or why would they be 90 degrees. So here we're going to find the dot product of u and v, then determine if u and v are orthogonal. So let's do the dot product. The dot product is multiplying the x's, negative 12, multiply the y's, that's plus 12, so 0. And we're going to say, yes, they are orthogonal. The dot product is 0. Let's get the dot product for this one. We have 16 plus, multiply the y's, 20, and that's 36. Those are not orthogonal. It'll be something other than 90 degrees. Use the dot product to find the magnitude. So the magnitude of A, of this vector, squared, is actually equal to the dot product with itself. So that's going to be negative 5, 12, dot product with negative 5, 12. And so the magnitude squared, and we can see that we're really doing the Pythagorean theorem. We're squaring negative 5, so that's going to be 25 plus, and we're squaring 12, 144. So the magnitude squared is equal to 169, and then we square root both sides. So the magnitude is the square root of 169, and that is 13. So they're saying, well, yeah, I mean, you're probably sitting there going, well, why don't we just find the magnitude? Well, that's because we're going to use the dot product, to find the magnitude. So we're just following the instructions. And here's a little bit of review. A plane has a bearing of 54 degrees with a speed of 380 knots. There's a wind with a bearing of 250 degrees and a speed of 60 knots. What is the resulting speed and bearing of the plane? So we're going to start out with a true bearing of 54 degrees. So let's start down the bottom left here. Here's the plane, let's say. Now this right here, that's the true bearing. That's 054. So the unit circle angle must be, let's see, I need this to be 36 degrees. With a magnitude of 380. Now on the end of that is the wind. Here's the wind. There's a wind with a bearing of 250 degrees, a bearing of 250, and a speed of 60 knots. So I got to go all the way around. Bearing of 250. Well, this would be 90, 180, and I'm going back this way like that. Going back like that. So that's 60 knots. Now I need the unit circle measurement, and I notice that 250 is 20 degrees short of 270. So this little tiny angle is 20 degrees, but I need the unit circle angle. I need that right there. So 180 plus another 20 is 200 degrees. Now we want the resulting vector. We want the resulting path of the plane. So we want that right there. Let's get the plane. The plane is 380 cosine of 36 degrees and 380 sine of 36 degrees. The wind is 60 cosine of 200 and 60 sine of 200. And let's use a calculator to get the result. .380 cosine of 36. I'm going to make sure I'm in degrees. I think I am. Yep. And we're going to add. Oh, I need to get the end. It brings it back to the beginning for some reason. Plus 60 cosine of 200. And while we're at the calculator, let's just get the other one. 380 sine of 36. And then we're going to add 60 sine of 200. So the component form of the resulting vector is 251. Oh, I forgot to store those in A, 045. I'll show you how you can go back and do that. 202.837. I want the whole number. We don't want rounded numbers during the process. So let's go up to this number, and we'll store in A. Store that in A. Then we'll go up to this one. Press enter, and we're going to store that in B. So you can always grab anything you've entered or any result. You can always arrow up and grab those. So this is in A. This is in B. So let's find the magnitude of R. That's the square root of A squared plus B squared. So let's do that on the calculator. Square root of A squared plus B squared. 322.7 knots. And you can see I worked it out earlier and got that answer. Now we need the angle. So let's get theta is equal to the inverse tangent of y over x. B over A, in other words, for this. Inverse tangent of B divided by A. 38.937 degrees, but that's unit circle talk. Now remember, we want the bearing angle to the result, to the resulting path. Well, if this right here, that's going to be the 38 degrees. So let's subtract 90. We're going to go 90, and we're going to minus that answer, which there's the 51, 051 degrees. So 051 degrees.